Welcome back, Gengies. We're just going to jump straight into it. We have more LeetCode to be done. The sickness is coming down. You can probably still hear it in my voice, but there's just more to do. So we did threesome closest yesterday. Or it took us 2 days, I think. One to do it in brute force, another one to figure out how to do it in n squared. N squared time. So that was pretty cool. So we're slowly making progress through the mediums. Hopefully it continues that way, but I think we're just going to jump straight into it today. And yeah. So I'm going to start the timer. 30 minutes, or if we do it and we have about 5 minutes left, we'll stop. But let's see. So here we have. I'll be right back. Okay, we're back. So we shall continue. So given a string containing the digits from 2 to 9 inclusive, okay, 2 to 9 inclusive, return all possible letter combinations that the number could, return all possible letter combinations that the number could represent. Return the answer in any order. Return all the possible letter combinations the number could represent. Return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, like on the telephone buttons, is given below. Note that one does not map to any letters. So for 23, we have AD, AE, AF, BD, BE, BF. Right. So we're pretty much given a string of numbers, and we have to figure out all the possible letter combinations the number could represent. that's the case, then I think the max number of, the way I'm planning to do this, the max length they could give us for digits has to be 4. Nice. So it is 4. So I think we can do this the way that I think. I think it's because we're trying to do an exhaustive generation of all the characters, but if we imagine it as nodes on a graph, for example, 1, and the number they gave us, 2, 3, 2 maps to 3 numbers, and so 3 also maps to 2 maps to 3 letters, and 3 maps to 3 letters as well. So we have 3 choices for each node. If we have 3 choices for each node, we can only be given a max of 4 nodes for 12 total possible choices, and an exhaustive generation on 12 choices is usually close to a crazy amount of time. Or when we have to generate a ton of combinations, 12 is usually our max, since it quickly approaches a ridiculous amount of time taken. So I think we can do this the way I was planning to do this. We could create a map of letter to the 3 combinations of letters you're allowed to have, and then we could simply generate all those combinations. Probably we could do it with a for loop, or maybe we could do it recursively. Do it with the for loop. I'm thinking something like 2 maps to ABC, so we'll choose ABC, right? Then we'll go through 3 and choose D, then we'll choose E, then we'll choose F, then we'll go back to A and choose B, then do D, then do E, then do F, then C, then do D, then do E, then do F. Might be easier to just do this recursively. If we do it recursively, then we can simply add the things we generate to an array. So I'm thinking we'll say combinations will be equal to an empty string array will return, and then we'll have a function called generate, which will take in digits as well as the map, as well as the combinations array. So from here we'll map the number, or the string to I guess we could map it to an array, or maybe it doesn't matter. We can also just map it to a string. We'll do 6, 7, 8, 9. So you have B, no. So you have D, E, F, G, H, I, J, K, L, M, and O, P, Q, R, S, T. Then we have X, Y, Z. This is going to be a map of string to string. Then we'll have combinations, right, which is an array, and we're not going to return anything. We would like to take 2, map it to A, and then for each letter in ABC, we'd like to generate the outcome of choosing D, E, and F. You could just do this with 4 for loops, but I'd like to do a version that supports more than that. Or maybe we should just do the 4 for loop version. is a for const op1 of map.get digits I guess one of the things we can also just do is just say if digits.length equals 0, we'll return an empty array. Then we don't have to have an if statement for this first section. So we can say digits sub 0. Alright, so now we have our first option. This is gonna get really messy, but then we're gonna have digits sub 1 in here. Then in here we'll duplicate what we did out there. We'll say digits.length is greater than or equal to 3. Then we'll have another loop in here where we'll do opt3. Right? But otherwise, what we push in here is actually just going to be then we can we'll say opt4. And we'll add this is really ghetto, but it is what it is. And then deep in here we'll get the full for opt. Oh, we have our things mapped incorrectly. 9 is WXYZ. 8 is TUV. So this works even though it's really ghetto. And it wouldn't work if we had to do, you'd have to manually add something to the if loop every single time. Is not flames. This is not ideal. I'm sure there's a gotta be a backtracking. I'm pretty sure there's a recursive backtracking version you can do of this. If we go back to the generate function, I'm pretty sure we need an IDX to start at. Just going to be a number. So we're going to start at 0. And then we're going to say I'm pretty sure we're also going to need a string to carry through, which will also start empty. We could say if IDX is less then we'll do some work. Otherwise it's greater than, which means that we should add it to we should add the string to combinations. So in here what we'll do is we'll say for const opt of map dot get digits sub IDX could call generate with IDX plus 1. So we go from, you'd pass in A, right? IDX plus 1 is less than digits dot length. So we do generate IDX plus 1, we'd now pass in A. I think we don't want to do plus 1. Let's say 1 is less than 2, which it is. So we're going to interpolate the string which is already there, which is which is A. We're going to add D to it, call generate again. Now IDX is going to be greater than digits.length, which means we'll push it on. Then we'll finish that. We'll finish that call and then go back to E path. Then we can do B. Yeah, I think this should work. Nice. So I'm pretty satisfied with that. I didn't think we'd be able to get there. Well, let's see what the solution has to say. The runtime of this is 12 factorial. So digits, they have the map, they have the combinations. Let's see this in Python instead. Letter combinations. They create a backtrack function. Just takes an index in the path. If the path is the same length as digits, we have a complete combination. True. Then you can add it to the combinations. Now we need to get the letters that the current digit maps to and loop through them. Oh, they did what we did, except they declared the function inside they made a closure so they don't have to pass in the functions, pass in the parameters. So you have access to combinations as well as digits. Oh, they append the letter, call the whole function again, and then undo the added letter by popping it. Interesting. I think that's good enough. We shall stop there.